Hey everybody, this video is all about going over some of the core math and algebra really, topics that you are expected to know for our physics class, okay? I'm going to run through a whole bunch of problems and you have a couple of different ways to approach this video. One, you could just watch the whole video, but also I should have some timestamps down at the bottom. Feel free to jump ahead to just review the part or parts that are applicable to you, parts that you think you need to look over in order to be prepared for this class. I'm just going to run through a bunch of problems. That's kind of how we're going to approach this video. Here's our first problem. I have it labeled 1A. 12 equals x minus 8. I'm just going to rewrite it in red, but it's the exact same problem. 12 equals x minus 8. It's asking you right here to solve for x. And the strategy, and this is actually the same thing that's going to show up on a whole bunch of my slides. What's the goal? What are you trying to do from an algebra perspective? We're trying to isolate our variable. What does that mean? It means whatever we're trying to find, x in this case, that's our variable, we want to get it all by itself. That's what it means to solve for x. We want to just know, what does x equal? For example, if we look over on this equation, this is not saying that x equals 12. It says that x minus 8 equals 12, or x, like take away 8 is 12. So we have a little work to do in terms of how do we solve this to finally prove what x is actually equal to. So how do I isolate this problem here? Okay, that's what I'm trying to do. Well, I want to get rid of this 8 that's hanging out. I don't want x minus 8, I just want x. So the main strategy is you want to do kind of the opposite that's next to the x in order to isolate it. What do I mean by that? This is, again, x minus 8. How do I get rid of this minus 8? I kind of do the opposite. I'm going to add an 8. If I just focus on this right-hand side, if I have x, originally I subtracted 8, but now I'm also adding 8, those two things cancel out. So they just kind of go away. They cancel. But do you remember the rule in algebra? Whatever you do to one side of the equation, you have to do to the other side. That's very important. So since I added 8 to the right-hand side, I also have to add 8 to the left-hand side. What's 12 plus 8? 12 plus 8 is the number 20. That's the answer to this problem. What does x equal? Here, x equals 20. Because I had x minus 8, I had to do the opposite to get rid of that 8. So I added 8, and I had to do that to both sides of the equation. Okay, there's our first problem. Second problem's kind of similar, but there's an extra little step. It's a little more advanced, but we are still trying to do the same thing, which is isolate our variable. First, I have 84 equals 3 plus 9x. I'm trying to solve for x here. First, let's get rid of this dangling 3. I don't want this 3. I just want to get ultimately x all by itself. If I have this 3, how do I get rid of it? Just like before, I'm going to subtract 3 from this side, and since I subtracted 3 from the right-hand side of the equation, I also have to subtract 3 from the left-hand side. 84 minus 3, that's 81. So now 81, this just canceled. These just went away. They got rid of each other. So I have just left over 81 equals 9 times x. Okay, now what do I do? I'm still trying to isolate x. I just want x all by itself. But here, I don't have x. I have 9x. I'm multiplying by 9. How do I get rid of this 9? I again kind of do the opposite. If I'm multiplying by 9, the way to get rid of it is actually to divide by 9. 9 divided by 9, that actually all cancels. That just leaves me with like 1. 1 over 1, that's just x. But since I divided the right-hand side by 9, I also have to divide the left-hand side by 9. What's 81 divided by 9? If you need a calculator, no problem. We'll need a calculator for at least some of these. It turns out that 81 divided by 9, that's 9. So that's the answer to this problem here. 84 equals 3 plus 9x. X is equal to 9. First I subtracted 3, but then I had to get rid of this coefficient, this thing that's being multiplied. I do that by doing the opposite. That's divide. And again, I have to divide by both sides. Whatever I do to one side of the equation, I have to do to the other. This is a common problem that students run into, maybe more than the other ones all combined, okay? What do I do when x is in the denominator? Team, I'm going to set this up in two different ways. The first way is a little bit of a hack, a little bit of a cheat. Okay, this is the hack. If I have 1 divided by x equals 10, if what I'm trying to solve for is kind of in the denominator, the trick is you pretend like you grab the thing in the denominator and you grab the thing that's on the other side of the equation sign and you swap them, okay? I mean, I swap their positions. So instead of 1 divided by x, I'll go back to yellow just to keep my original stuff. I haven't moved that 1. I still have that divide by. But instead of dividing by x, I'm going to swap it with what's over here. 1 divided by 10. And that's going to be equal to, not 10 over here, just x. So this is actually the answer for this problem right here. If 1 over x equals 10, x is equal to 1 divided by 10, or that's the same thing as 0.1. I always like a decimal in my class, okay? Now, where does this little trick come from? It does come from algebra. I'm again going to rewrite the problem just because it's a little easier for me to rewrite it sometimes. A lot of students say, like, you want to divide both sides by the number 1. That doesn't actually help me here because x is in the denominator. It's in the bottom of the fraction. So the way I solve for it algebraically is a little weird. I got to get x out of the denominator. So the way I'm going to do that is first going to sound counterintuitive. I'm going to multiply both sides by x. Remember, whatever I do to one side of the equation, I have to do to the other side. Now, if you think, well, wait a minute, if I multiply both sides by x, isn't that going to cancel? And you're absolutely right. If I have x here, and this is in the numerator, it's on the top. Down here, x is in the bottom. It's just like I have x divided by x. Those do cancel out, which means I just have like, there's nothing here. There's just 1. 1 divided by 1. I just have 1 over here equals 10 times x. But that's an important step because I had to get that x out of the denominator. Now it's over here. So now it's at least familiar. This is now similar to the last problem we did. I have 10x. How do I get rid of this 10? I just want to solve for x all by itself. I want to isolate my variable. How do I get x alone? I'm going to divide by 10 now. Because 10 divided by 10, that's just going to cancel. But again, whatever I do to one side of the equation, I have to do to the other. So ultimately I'm going to switch colors one last time. I have x is equal to, there's that 1 over 10. Oh, it's the exact same thing I have here. So this is the algebra steps, and that is valuable to know. But also, to be honest, team, sometimes I tell students, can you remember this little cheat? If what you want to solve for is in the denominator, you can pretend to grab it, grab the thing that's on the other side of the equation, and you can flip them. Okay, but either way, either of these methods are going to work for this setup. All right, moving right along, on to the next problem. Okay, here I have 5x squared equals 60. So now what do I want to do? Same strategy. I want to get x all by itself. So there's a few things that are kind of getting in the way of my x being all alone. The first thing is there's this coefficient again. I have 5 times x squared. I want to get rid of that 5. What do? I'm going to divide both sides by 5 because 5 is multiplying. If I divide, that's going to cancel. So that's just going to leave me with x squared on the left-hand side. On the right-hand side, what is 60 divided by 5? Again, bust out your calculator if you need it. No problem. You are always allowed a calculator, at least in my class when we're doing problems. It turns out that 60 divided by 5 is equal to 12, okay? So now I have x squared equals 12. Now what do? I have x squared. I don't want x squared. I just want x. I want x all by itself. I'm going to do the same idea of what I said before. When I want to isolate x, I want to kind of do the opposite. Right here, x is being raised to the second power. Do you remember from math class, how do you undo an exponent? Or said another way, what's the opposite of squaring something? It turns out, team, that's taking the square root. I'm going to take the square root of this. Taking the square root of x squared actually cancels out that x squared. I'm just going to be left with x. But, again, whatever I do to one side of the equation, I have to do to the other. So I'm just left with x on the left-hand side, but on the right-hand side, I need to use my calculator. I don't know what this is off the top of my head. I need to find the square root of 12. I don't know if you'll be able to see my calculator as I hold it up, but the square root of 12, what does it turn out to be? About 3.5. 3.5. You might round it as like 3.46. Totally fine. But again, I'm trying to isolate my variable. First, I got rid of that 5, and then to undo a square, I take the square root. Okay, moving on, not too many more. I did want to go over another problem that is similar. Okay, now I have that square root here. Okay, I have 15 equals 7 plus the square root of f. Let's solve for f this time. Again, let's get rid of this first 7, all right? Right here I have this 7 that's being added. How do I get rid of it? I'm going to subtract 7 from both sides. Let me change colors. I'm going to subtract 7 from this side. That means I'm going to subtract 7 from this side. Okay, well 15 minus 7, that's equal to 8. And then what's left over here? This 7 just got canceled out, so I'm left with the square root of f. Okay, again, I want to isolate my variable. I just want f. I want to find out what f is equal to. I don't want what the square root of f is, so I got to get rid of this square root. How do I undo it? I'm going to do the opposite. What's the opposite of taking the square root? Oh man, it's squaring. It's kind of like the opposite of our last problem. If I square a square root, that just undoes it. It's like this whole thing gets canceled out. So I'm just left with f. But whatever I do to one side of the equation, I have to do to the other. I have to do 8 squared. Use your calculator if needed. What is 8 squared? It turns out 8 squared is 64. So in this problem, bam, f is equal to 64. Okay, just about done, everybody. I think this might be our last problem, okay? A little longer in terms of its setup, but it's still us doing the same kind of things, okay? This problem actually gives us multiple variables, but we're actually going to be given and we're actually going to be plugging in things. This is actually a little bit more like our classic physics problems where we are going to learn equations, physics equations, and there might be multiple possible variables. The speed of something, the distance something has traveled, etc. And you'll be told what some of those values are, and you're going to be asked to solve for something else, okay? So here's my equation, y equals 9x plus b. It says if y equals 5 and b equals 2, let's solve for x, okay? Well, I already have my equation. Let's go ahead and start plugging things in. Instead of y, I have 5. So I have 5 right here. It's not always going to be 5, but in this case, I tell you that y equals 5. So instead of y, I'm going to write down 5. Now let's set equals here. 9 isn't changing, so I'm still writing 9. I'm solving for x, so that's still a variable. It's still an unknown. Plus b. Oh, but I'm told that b is equal to 2. Okay, so now it's actually kind of going back to the types of problems that we've already been dealing with, all right? Now, I'm trying to get x all by itself. I'm trying to isolate my variables. What should I do? First thing I'm going to do is I'm going to subtract 2 from both sides of the equation. 5 minus 2 is 3. 3 equals 9x. And I don't have to worry about that 2 anymore because since I subtracted a 2, it just goes away. All right, now what am I going to do? What do you think? I'm trying to solve for x, so I want to get rid of this 9 right here. 9 is being multiplied, so I want to do the opposite. I'm going to divide by 9. 9 divided by 9, that cancels. But whatever I do to one side of the equation, I have to do to the other. So I have x is equal to 3 over 9. It's not terrible leaving your answer as a fraction, but to be honest, in science class, decimals are basically always preferred. 3 over 9 is the same thing as 1 over 3. That's about 0.3, or you could say 0.33, 0.333, but that's, I'm just going to write the x over here just so we see it a little cleanly. X is equal to 0.33, okay? It's about a third. All right? Hopefully that was helpful, you looking over some different types of math problems and reminding yourself the algebra steps that we need, because again, these are the kinds of problems that we're going to see in our physics class. All right? Thanks a lot for watching.